Okay, hi everyone, welcome back to this video series on cryptocurrency. Changing the consensus rules. The rules of consensus determine the validity of transactions and blocks. These rules are the basis for collaboration between all Bitcoin nodes and are responsible for the convergence of all local perspectives into a single consistent blockchain across the entire network. While the consensus rules are invariable in the short term and must be consistent across all nodes, they are not invariable in the long term. In order to evolve and develop the Bitcoin system, the rules have to change from time to accommodate new features, improvements, or bug fixes. Unlike traditional software development, however, upgrades to a consensus system are much more difficult and require coordination between all the participants. Hard forks. In blockchain forks, we looked at how the Bitcoin network may briefly diverge, with two parts of the network following two different branches of the blockchain for a short time. We saw how this process occurs naturally as part of the normal operation of a network, and how the network reconverges on a common blockchain after one or more blocks are mined. There is another scenario in which the network may diverge into following two chains, a change in the consensus rule. This type of fork is called a hard fork because after the fork, the network does not reconverge onto a single chain. Instead, the two chains evolve independently. Hard forks occur when part of the network is operating under a different set of consensus rules than the rest of the network. This may occur because of a bug or because of a deliberate change in the implementation of the consensus rules. Hard forks can be used to change the rules of consensus, but they require coordination between all participants in the system. Any nodes that do not upgrade to the new consensus rules are unable to participate in the consensus mechanism and are forced onto a separate chain at the moment of the hard fork. Thus, a change introduced by a hard fork can be thought of as not forward compatible, in that non-upgraded systems can no longer process the new consensus rules. Let's examine the mechanics of a hard fork with a specific example. Figure 10.9 shows a blockchain with two forks at block height 4 and one block fork occurs. This is the type of spontaneous fork we saw in blockchain forks. With the mining of block 5, the network reconverges on one chain and the fork is resolved. Later, however, at block height 6, a hard fork occurs. Let's assume that a new implementation of the client is released with a change in the consensus rules. Starting at block height 7, miners running this new implementation will accept a new type of digital signature. Let's call it a S'mores signature that is not ECDSA based. Immediately after, a node running the new implementation creates a transaction that contains a S'mores signature, and a miner with the updated software miners block 7B containing this transaction. Any node or miner that has not upgraded the software to validate S'mores signatures is now unable to process block 7B. From their perspective, both the transaction that contains the S'mores signature and block 7 that contained the transaction are invalid because they are evaluating them based upon the old consensus rules. These nodes will reject the transaction and the block and will not propagate them. Any miners that are using the old rules will not accept block 7b and will continue to mine a candidate block whose parent is block 6. In fact, miners using the old rules may not even receive block 7b if all the nodes they are connected to are also obeying the old rules and therefore not propagating the block. Eventually, they will be able to mine block 7a, which is valid under the old rules and does not contain any transactions with small signatures. The two chains continue to diverge from this point. Miners on the B chain will continue to accept and mine transactions containing small signatures, while miners on the A chain will continue to ignore these transactions. Even if block AB does not contain any s'mores signed transactions, the miners on the A chain cannot process it. To them, it appears to be an orphan block as its parent 7b is not recognized as a valid block. Hard forks, software, network, mining and chain. For developers, the term fork has another meaning, adding confusion to the term hard fork. In open source software, a fork occurs when a group of developers choose to follow a different software roadmap and start competing implementation for an open source project. We've already discussed two circumstances that will lead to a hard fork: a bug in the consensus rules and a deliberate modification of the consensus rules. In this case of a deliberate change to the consensus rules, a software fork precedes the hard fork. However, for this type of hard fork to occur, a new software implementation of the consensus rules must be developed, adopted, and launched. Examples of software forks that have attempted to change consensus rules include Bitcoin XT, Bitcoin Classic, and most recently Bitcoin Unlimited. However, none of these software forks have resulted in a hard fork. While a software fork is a necessary precondition, it is not itself sufficient for a hard fork to occur. For a hard fork to occur, the competing implementation must be adopted and the newer rules activated by miners, wallets, and intermediary nodes. Conversely, there are numerous alternative implementations of Bitcoin Core and even software forks that do not change the consensus rules and, barring a bug, can coexist on the network and interoperate without causing a hard fork. Consensus rules may differ in obvious and explicit ways in the validation of transactions or blocks. The rules may also differ in more subtle ways in the implementation of the consensus rules as they apply to Bitcoin scripts or cryptographic primitives such as digital signatures. Finally, the consensus rules may differ in unanticipated ways because of implicit consensus constraints imposed by system limitations or implementation details. An example of the latter was seen in the unanticipated hard fork during the upgrade of Bitcoin Core 0.7 to 0.8, which was caused by a limitation in the Berkeley DB implementation used to store blocks. Conceptually, we can think of a hard fork as developing in 4 stages: a software fork, a network fork, a mining fork, and a chain fork. The process begins when an alternative implementation of the client with modified consensus rules is created by developers. When this fork implementation is deployed in the network, a certain percentage of miners, wallet users, and intermediate nodes may adopt and run this implementation. Our resulting fork will depend on whether the new consensus rules apply to blocks, transactions, or some other aspect of the system. If the new consensus rules pertain to transactions, then a wallet creating a transaction under the new rules may participate a new network fork followed by a hard fork when the transaction is mined into a block. If the new rules pertain to blocks, then the hard fork process will begin when a block is mined under the new rules. First, the network will fork nodes based on the original implementation of the consensus rules, will reject any transactions and blocks that are created under the new rules. Furthermore, nodes following the original consensus rules will temporarily ban and disconnect any nodes that are sending them these invalid transactions and blocks. As a result, the network will partition into two. Old nodes will only remain connected to old nodes, and new nodes will only be connected to new nodes. A single transaction or block based on the new rules will ripple through the network and result in the partition into two networks. Once a miner using the new rules mines a block, the mining power and chain will also fork. New miners will mine on top of the new block, while old miners will mine a separate chain based on the old rules. The partitioned network will also make it so that the miners operating on separate consensus rules won't likely receive each other's blocks, and they're connected to two separate networks. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.